Hello everyone, my name is Priyanka Honwad and my teammate Vani will be presenting our internship project titled Simulation of Microwave Oven using PicSimLab and MPLab IDE. So this project focuses on understanding how an embedded system controls a real-world appliance by integrating microcontroller, programming, user interfacing, and timing control. So here I will begin with a brief overview of this project, followed by the architecture, working principle, and many more. So the topics learned during this internship is Introduction to languages, Array, Pointer, String, Functions, and Loops, Introduction to Embedded Systems, Microcontroller, MPLab X IDE, XC8 Compiler, and PicSimLab, Introduction to various peripherals of 16F877A. So the requirements during this project is the software MPLab X IDE, XC8 compiler, PicSimLab, PIC16FC F877A microcontroller board. So let us understand what is C programming. So here, introduction to C program. C is general purpose programming language developed by Dennis Ritchie in 1972 at Bell Laboratories. So C is widely used programming language for embedded systems due to simplicity, efficiency, and close interaction with hardware. It allows direct access to memory and hardware registers using pointers and bitwise operations. C programs are fast and require less memory, which is important for source resources constrained embedded devices. It supports structured programming, making embedded software reliable and easy to maintain. Hence, C is preferred language for developing firmware for microcontroller and real-time systems, as we are doing the project on this microwave control. So, concepts of C. The concepts of C learned during this internship is the array, pointers, string, function, loop. So array is nothing but it is used to store multiple sensor readings or data in a contiguous memory. Pointer is used as an access memory location, hardware register, and peripherals directly. Strings used for displaying messages and serials or LCD communication. Functions which helps dividing the embedded programs into reusable and manageable tasks. Loops which is used for continuous execution like sensor, monitoring, and control operations. So let us understand what is embedded system. An embedded system is an electronic system designed to perform a specific function and is combination of both hardware and firmware, like software. Embedded system is unique and hardware as well as firmware and highly specialized to the application domain. So the characteristics of embedded system are dedicated functionality, real-time operations. So what is a dedicated functionality? Embedded systems are designed to perform a specific set of functions or tasks such as controlling a micro oven. Real-time operation is many embedded systems must respond to external event in real time, meaning they need to process and generate outputs within a strict timing constraints. So here is a current source and current sinking. The first diagram is of current source and the second diagram is of current sinking. So in current source, a circuit provides current to a load. A current flows out of the output pin or device into the load. The device is acting like the supplier of the current. So here is the load. This is the device. The current flows out of here is the current flowing out of the device. So imagine the output pin is giving current to the load. That's the current sourcing. That is this current sourcing. Next, for example, let us take a microcontroller pin set high, that is plus 5 volt, that sends current to the LED. This sends the current to the LED to a LED which is connected to the ground. The pin sources current to the light LED. So here what happens is the device output goes high, current flows out of the load then returns current to the ground. So the next is the current sinking. In current sinking, the circuit receives current from the load. The current flows into the output pin or the device. So here as it going, current was flowing of the output pin or the device. Here the device is acting like a receiver of current. Here imagine the load pushes water into the device, that is current sinking. For example, let us take an LED connected to the 5 volt and a microcontroller pin at the other end goes low to full current through the LED to the ground. Here the pin sinks the current. So here the result is the load is connected to the positive supply plus 5 volt. The device pin goes low to the ground. Current flows from plus V to the load, from load to the device pin, and from device pin to the ground. So next one is pull up and pull down resistor. So the first diagram is a pull up resistor. Pull up resistor is a resistors which are used to ensure that a wire is pulled to high logically value in the absence of input signals. Whereas the pull down resistor, these work in same manner as pull up resistor, except that the pull except that they pull the pin to the logical low value. Next, we have the matrix keypad. So, this is the keypad in which the number of tactical switches are connected in a row. That is, this is in a row and this is in a row and columns. This is used when more number of inputs are required. So, as we require more number of input during this project, so these matrix keypad has been used. These are most commonly used in calculator, digital lockers, etc. The rows are configured as output by giving logic 0. The columns are configured as inputs by giving logic 1. Then we have character liquid crystal display, which is shortly called as CLCD. So in PicSimLab, there are two types of display, that is 16 cross 2 display and 16 cross 4 display. It is used to display the ASCII 2 characteristics, communication modes, 8-bit mode and 4-bit mode. So as we need more number of rows in our project, so here we are using 16 cross 4 display and 4-bit mode because our tacticals which is allowed to connect some port, which is the port D, in which matrix keypad is being connected. So then we have interrupt. So an interrupt is a communication process set up in a microprocessor or microcontroller in which an external or internal devices request the MPU to stop the processing. The MPU acknowledges the request, attends to the request, goes back to processing where it was interrupted. Then we have ISR. ISR is interrupt service routine, which is defined as a software routine that hardware invokes in response to the interrupt. This examines an interrupt and determines how to handle it and executes the handling and then returns to the logical interrupt value. So when interrupt occurs, the MPU completes the instruction being executed, disables the interrupt enable, and places the address from the program counter to the stack. So then next we have is a timers. Timers is nothing but a simple binary counter that can be configured to count clock pulses, both internally as well as externally. These are used to measure the time or generate an accurate time delay. So in PicSimLab, for the board PicSim 16F877A, we have three timers, that is timer 0, timer 1 and timer 2. For our project microwave oven, we are using timer 2. So microwave oven, the main purpose of our project. Microwave oven is a kitchen appliance that uses electromagnetic radiations in a microwave frequency range to heat and cook the food. So there are three modes in the microwave oven. That is microwave mode, grill mode, convection mode. Another one is a start mode. Microwave mode is nothing but it is the standard mode where the microwave oven emits microwaves to heat and cook the food. Next is a grill mode. This mode allows you to grill the food by exposing to a high heat from below. This works for thinning thinner pieces of food such as burger, breads, etc. and some more. Convection mode. Here, a fan is used to circulate hot air, which help the browning and crisping of food. This mode is suitable for baking and roasting. So, PicSim architecture, PicSimLab architecture. So, the architecture represents a complete virtual embedded system built around the PIC16F877A microcontroller in PicSimLab. The PIC16F877A acts as a central processing and control unit, interfacing with both analog and digital peripherals. Analog inputs such as LM35 temperature sensor are processed through the ADC, while RTC and EPROM communicate using RTC and EP communicate using I2C protocol for timekeeping and non-volatile data storage. Next, we have GI, GPIO. These are the ports which handle general digital input and output operations. This one, GPIO. Then on the output side, this is the output side. On the output side, we have the microcontroller drivers such as LEDs, buzzer, matrix keypad, we RS-232, buzzer, etc. User interaction is achieved using matrix and digital keypads. So here Pixum Lab accurately emulates real-time hardware behavior, making it effective platform for embedded system design, testing, and learning without physical hardware. So the next is a PIC 16F877A microcontroller board, which consists of the matrix board. Here is the matrix keypad. Next, we have the ports over at the bottom. This is PIC 16F877A IC. This is the fan and this is the buzzer. And this is nothing but CLC display. Thank you. So now I would like to hand over my teammate Vani Interrogator to explain the working process of the microwave oven.
Hello everyone. I Vani here to explain working of micro oven in this project. Now let us look at the PicSimLab software used for the simulation of microwave oven. Here we have used the board that is Pic Genius, and the microcontroller used here is Pic 16F877A, and uh, these are the matrix keypad. These are the 16 LEDs, and these are the ports present at the bottom. And this is the IC that is PIC 16F877A. Here is the fan present and buzzer, and this is the relay. And this is the CLCD display. Now, I have used the software for uploading the codes, that is MPLab XIDE. Here there are main.c where all the case conditions and loops are being declared for the execution. Micro1.h file is present where the functions are defined, and here is the CLCD header file, microwave oven dot c clcd dot c, my matrix keypad timers matrix keypad dot h, that is header file, and next is ISRC. Now, next we to upload these all codes in the board, we need to go on the file. Next is load X, where the codes are being loaded to the board. First, here it will show the power on message. Next, it will display the four modes, that is micro mode, grill mode, convection mode, and start mode. Inside the micro mode, the food will start cooking. So to on this micro mode, we need to click on the first button, which will show the power, that is 900 watt. Next, it will allow us to set the time. So let us set the time as 20 seconds and 1 minute, that is 1 minute and 20 seconds. Now if we want to clear this time, we need to click on the star, which will clear the time. Next, to enter this, we need to click on the hash button, which will enter the time. And here the fan rotates for 20 seconds. Here the timing will down count, and we'll get the three options, that is start, stop, and pause. To pause this, we need to click on 5, which will pause the time and fan. And next, to restart it, we need to click on 4, which will start the fan and time. To stop it, we need to click on 6, which will automatically take us to the previous step. Now second is the grill mode where the food has been grilled. To start this mode, we need to click on button 2, which will start the grill mode. Even this will allow us to set the time. Let us give 25 seconds here, and by clicking on hash it will start the fan, and the even here the time will down count, and even here there are three options, that is start, pause and stop. Now let us directly stop it. Next is third mode, that is convection mode, where the preheating of the food takes place. To start this mode, we need to click on button 3, which will start the convection mode, and here it will allow us to set the temperature, at what temperature the food is been cooked. Next, let us give us 25 degrees Celsius. To enter this, we need to click on hash, which will start the time preheating. Even here, the time will down count, and time remaining for the to start the cooking of the food. Now, after this time is get after that this time gets over, it will automatically go to the set time, which will allow us to set the time at what time we want to cook the food. This is how it is showing, like it is decreasing the time. When this time becomes 0, it will automatically allow us to set the time, and after setting the time this fan rotates and the food will cook. uh, Yeah, now you can see here it will allow us to set the time. Let us give 20 seconds, then enter. See, now the fan rotates, and even here it will allow us three options, that is start, pause, and stop. Let us stop it. Next, we have fourth mode, that is start mode. To start this mode, we need to click on button 4. Here, by default, 30 seconds has been fixed as we have declared it in the code. Then, if we want to add again some time, then we need to click on button 4, which will add by 30 seconds again. See, as you can see here, it becomes again, it will add 30 seconds. Then again, if you want to click on 4, it will again add the 30 seconds. Now, again, we have here three options, that is start, pause, and stop. Then let us pause it. Click on button 5. Then again start it. Then if we want to stop, then 6. It is stopped. Now, this is the microwave oven simulation, and I thank the Emertxe for giving us the opportunity to gain such interesting knowledge. And thank you.